is talking about the area of a triangle. It has a specific way to use determinants and matrices and the information that is given. It's always plus minus 1/2 because you don't know which one you're going to use. The x values, the y values, and always 1. It always follows this pattern. Very simply, if the determinant is negative, we use the negative 1/2. If the determinant is positive, we use the positive 1/2. Because area is always positive, so we want it, whenever we multiply by the 1/2, we need it to come out to be a positive number. So here on this example, we want to find the area of the triangle with these vertices. So we put all of our x's down the first column, so 1, 2, 4. Then we put our y's down the second column, 0, 2, 3. And then we always put 1 down the third column. And in the last section, we found the determinant of a 3 by 3, so that's exactly what we're going to do. We're going to use our first row, so we're going to take 1, and then the determinant of the leftover, 2, 1, 3, 1, and we're going to subtract 0, and in that case, 0 times anything is 0. I don't need to go any farther than that. And then plus 1, and its leftover is 2, 2, 4, 3. So the determinant here is 2 subtract 3. And here we're going to get 6 subtract 8. And since this times 1, it doesn't really affect anything. So I get my determinant is negative 3. Now I'm going to multiply it by the negative 1/2 because my determinant was negative. I need it to always be positive, so in this case the area is 3/2. 3 points are considered to be on the same line if the determinant is above 0. Let's look at this next example. We're going to put our x's in the first one, y's in the second one, and 1's in the third. In this case, we're going to take negative 2 and then times the leftover, subtract a negative 2 and its leftover, and then add a 1 to its leftover. All right, so here we're going to get negative 2 times 1 subtract 5, or negative 4. We're going to get 2 times 1 subtract 7, and we're going to get 1 times 5 subtract 7. So we get positive 8, negative 12, negative 2 for a total of negative 6. Because it is a negative, we want to multiply it by a negative 1/2. So that 3, positive 3, is the area of the triangle with those vertices. All right, so let's move on to page 2. All right, Cramer's rule is another way to solve systems of equations using determinants. We'll solve the following using Cramer's rule. What we do is we find x and y by taking the determinant of x divided by the determinant of the whole thing. So in this case where I have the system 4x minus 2y is 10, 3x minus 5y is 11. We have many ways to solve this. We can graph them, we can substitute them, we can eliminate them. We now know how to do the row echelon. We know how to use our matrices and our calculator to do the inverses. So Cramer's rule is another way to solve the exact same thing. You will be asked to do it using Cramer's rule. So let's go through this process. First thing we need to do is find the determinant of the whole thing. So I want to find 4, negative 2, 3, negative 5. Because remember, the determinant does not use the answers. So in this case, I'm going to get negative 20, subtract a negative 6 for a total of negative 14. So we find the determinant of the whole thing. Now we're going to find the x value, we take the determinant according to x over the determinant of the whole thing. Well, what that means is that we're actually going to replace the x, because remember these are x's, these are y's. We're going to replace the x's with the solutions. So I'm really going to put 10, 11, and then negative 2, negative 5 all over the determinant of the whole thing. So in this case, I get negative 50, subtract a negative 22, which is negative 28 over negative 14, for the x value of 2. All right. So I'm going to do the same thing to find y. The determinant according to y over the determinant of the whole thing. So this time I'm going to replace the y values with the solutions. So leave the x and replace the y with the solutions all over the determinant of the whole thing. So that determinant is 44 minus 30 over negative 14, which is 14 over negative 14, which is negative 1. The solution is 2, negative 1. And you're welcome to graph that, put it into your calculator, solve it with elimination, whatever it is, to prove that that's your actual solution. But this is how we do it using Cramer's rule. Okay, so let's look at a 3 by 3 here on this matrix. So the matrix here is going to read negative 1, 0, 1, 2, negative 1, 1, 0, 1, negative 3. And it would read that if you could see the numbers, of which you still can't. Let's see here. All right, put the coefficients in and then use that. Doesn't help any. Let's see if I can get them to show a little bit better. No, not so much. Okay. In this case, I'm going to find the determinant of the whole thing. The determinant is negative 1, and then the cross multiply, so 3 minus 1 minus 0 times doesn't matter because the 0 times anything is not going to matter. And then a 1 times the 2 minus 0, which is the determinant of the other place. So here we're going to get negative 2, 0, plus 2. The determinant is 0. If the determinant is 0, you can't use Cramer's rule. You'd have to find another method, because that means there's something special going on here. Either no solution or infinite, or there's something different going on here. So if you come up with a determinant of 0, you're done. Cramer's rule, move on. All right, with a part B here, we're going to set up the coefficient matrix. So we're going to find the determinant according to that coefficient matrix. So we get negative 1, and then the 2, and then the negative 3, so we get negative 1 times 4, negative 2 times 5, negative 3 times negative 8, for a total determinant of 10. Now that's the determinant of the whole problem. So if I want to find x, y, and z, and I do because those are my letters, I'm going to find x first by taking the determinant of according to x over the determinant of the whole thing. Now keep in mind the determinant of x means I'm going to replace the x values with the solutions. So I'm going to make it 1, 0, 2, and then leave the y's, leave the x's, all over the determinant of the whole thing. Now, long process again, because we have to take 1, cross off 1, do the leftovers. Oops, that should be 3, 1, negative 4. So we get 0 minus minus 4, 2, and our negative 3. All over 10. Well, that gives us, we're going to get 4 and 4. We're going to get 8, so 8/10 is 4/5. All right, now we're going to find y. So the determinant of y over the whole thing means we're replacing the y values. So the y values become 1, 0, 2, and the x and z are normal, all over the total determinant of 10. Then you're going to do the same thing for z, do the determinant according to z, meaning the x's stay, the y's stay, and the z's become the solutions, all over 10. I want you to finish working this out, come up with the y and the z of this triple coordinate. All right, and then the last page we're going to work on in class about coding messages. So there is 8.5.